Section 6.4 is on simplifying radical expressions of nth roots. So in Algebra 1, you simplified square roots. Maybe you took a look at cube roots. Today we're going to review simplifying square roots, but also looking at higher order roots. So let's recall what a radical expression looks like. Here we have that our radical symbol is the checkmark-like symbol, and whatever value is out front that is small, we call our index or our root. When there's not a value, we just say a square root, right? So if I have something like this, the square root of 4, that just means square root. If I have something like this would mean to do the cube root, and so forth. I could have a little 4, I could have a 5, a 6, a 7. But whatever that small number is, that's our index or root. And whenever there isn't a number there, we assume it's a 2 for a square root. Inside the radical symbol, we call that the radicand. So it could be a single term like the number 4 that I wrote, or it could have lots of variables and coefficients involved. Now, when we're simplifying our roots, we often are asked just to find the principal root. And the principal root is the even root. So remember, when we take square roots on our own, we usually take the plus or minus. If we just see that square root or cube root or fourth root symbol, it's really just asking us to find the even root for that principal root. Now, sometimes if it's an odd power, we could get odd answers as well. Negative answers as well, I apologize. So let's take a look at simplifying. We'll do a couple together and you'll do some on your own. So this is saying find the principal root of 25. Remember, both 5 squared and negative 5 squared gives me 25, but we just want the positive answer. So this is simply just 5. B, on the other hand, is saying give us the negative square root of 100. So we bring our negative sign down, and then the square root of 100 is 10. So we get negative 10. You try C and D. Now, C is asking for cube root, so recall your perfect cubes. And then D is a fraction. You're just going to take the square root of both the numerator and the denominator. Okay, now let's review some rules with absolute value. So when we have variables inside our radical, we have to keep in mind that what's inside has to be a positive, right? We don't want negatives, otherwise we get imaginary answers. So when I have variables, we have to think about absolute value. It's saying make that answer be positive, so we ensure we don't get imaginary answers. So here's our general rule. If we have a root that is even, okay, so my little index is even, the power inside the radicand is even, but the resulting power outside is odd, you must use absolute value. So even comes out odd, and that's in terms of powers, not coefficients. So if we look at our first example, that's a square root. So that's an even root, right? So an even root of 2. Inside, we have a power of 2. And now when I simplify that, let's think about what that outside power is. Okay, so now let's focus on simplifying, and then we'll discuss the power and absolute value. So recall when we do these, this is really like a little 2 here. So we say 2 goes into 2 one time. So x to the first comes out, and we aren't left with anything left over. So I simply get x to the first. So the power on the outside of the radical is a 1. This means even root to begin with, even power on the inside, comes out odd. So that means my answer needs absolute value. So we will write this as the absolute value of x. Let's look at B. Okay, let's simplify first. So again, this is really a square root. So we say 2 goes into the power of 4 twice. So that means x squared comes outside. There's nothing left inside. Now 2 goes into 2 for the y squared once. So y to the first comes outside. And 2 goes into 6 3 times. So z to the third comes out. There were no remainders, so there's nothing left in my radical. Now we check our absolute value. Let's check for x. Even root to begin with, even power of 4 came out even, so we don't need absolute value. For y, even root, even power came out as to the first, which is odd. That will need it. And z, 2 and 6, even, but came out to the third, which is odd. So that will need it. So instead of doing separate around y and then around z, I can just simply put it both around y and z. So there's my answer. Okay, let's look at C. This one is saying the fifth root of x plus 2 to the fifth. So this is our quantity all to the fifth power. 5 goes into 5 once, so that means the quantity of x plus 2 comes outside, and I'm not left with anything. Now we check our absolute value. Even come out odd? No, it was odd to begin with, so I don't even worry. And so here's my answer. Okay? You'll have more to practice afterwards. So let's talk a little bit about simplifying, and we'll do some, and then I'll have you try them on your own. When we're simplifying, there's 4 things you need to make sure of. The index cannot divide into the powers in the radicand any further. So that means that the inside powers must be smaller than the root itself. You cannot break up numbers in the radicand. So for example, if I have the number 12 inside the radicand, we can break that into perfect squares, so it wouldn't be fully simplified. 3 is that there's no fractions in our radicand. Remember, we'd have to rationalize. And same thing, no radicals in our denominator. We have to rationalize. So let's look at some of these together, and then you can try some on your own. So for A, we have the cube root of -8. So recall cube roots, and we can make a little list. Why don't we make a little list right now of some of our perfect squares and then some of our perfect cubes that you should know. Okay, so I'll just do that on the side. You can put this anywhere on the top of the notes, wherever you'd like. But for our perfect squares, we know 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, and that to 225 is where you should know up to, but then anything kind of like 20s, 40s, 30s, etc., you should also know. Okay, so those should be all the ones that you easily can recognize. In terms of cubes, we don't need to go as high, but we know that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 to the third power is 216, and then I'd say at 10 to the third is 1,000. These ones definitely you should know. The ones that I'm leaving blank may show up, right? So 7 cubed, 8 cubed, 9 cubed may show up, but you will see the ones I've written most frequently. So be familiar with those values. So with that being said, let's go back to A and let's simplify. So the cube root of -8. Well, do I know the cube root of -8? Yes. What times what is 8? It's okay to have a negative there. I get -2. Nothing left on the inside. Now let's go to x to the third. The cube root of x to the third, 3 goes into 3 once, so x to the first comes out. Now to the y. 3 goes into 5 one whole time, but we're left with 2 left over. So that means y squared is left inside. Don't forget about putting your cube root. Now, do we need absolute value? No, because it wasn't an even root to begin with. Now we double check those rules up above. So the index cannot divide into the powers, right? So 3 can't go into 2. 2 is smaller on the inside, so we're good to go. There's no numbers on the inside, right? No coefficients, so we can't break that up. And there's no fractions, so we don't need to worry about that. So there's my answer. Let's look at B. B, recall here, we aren't going to just say, let's take the square root of x squared. Let's take the square root of 4x. Let's take the square root of 4. We are not going to do that like we did with the first one. This is attached with a sum. So what we first need to do is we need to factor that. So this is going to become the square root of, and this is a perfect square trinomial, x plus 2 all squared. Now we can actually take the square root, right? There's a little 2 right here. So 2 goes into 2 once, so that means the quantity of x plus 2 comes out, and there's nothing left inside the radical. However, this time, that power on the outside is a 1, so even came out as an odd power, so we need absolute value bars around our answer. Okay? I'm going to do D with you, and then you can try C, E, and F on your own. So for D, when we see decimals, it's really important if it's a square root that it's an even amount of decimals, because when we are multiplying, we add decimals. So remember, powers is a way of multiplying. If we have an odd amount of decimals and I have a square root, that wouldn't make sense, right? We can't add the same amount to get an odd. So I have an even amount, which is good. And I just think about the square root of 16. The square root of 16 is 4. But now we think about that decimal spot. There was 2 in my answer, or 2 in the original problem. So when I take that square root, there should really just be 1. Because if I went back to check, right, if I did 0.4 times 0.4, we would add those 2 decimals together, which would make 2 decimal spots. Okay? So again, it could say 0.0016, and that would be okay because it's 4 decimals. But anytime we have an even root, we better have an even amount of decimal spots inside. All right, you try those other 3. Lastly, let's do some approximating. So you'll see in your homework or your classwork for when we come back from break is that you will have some approximating to do, and sometimes it says use a calculator. We're going to do that without a calculator. So when we're approximating, we want to think about what 2 integers this value is in between, and then try to get as close to the decimal as possible. So I know that 47 is really close to the perfect square of 49. And I know the square root of 49 is 7. Therefore, the square root of 47 is going to be really close to 7, but since it's a smaller number, it won't quite be at 7. So something like 6.8 or 6.9 would be the best approximation. And what I should do is, instead of an equal sign, use my approximation symbol. So I'm going to say the square root of 47 is approximately 6.9. Now, if I was to actually do the square root of 47 on a calculator, we get 6.85. So there you have it, close to 6.9. Okay? You try doing B and C. Approximate those. So what perfect square is 135 close to? For C, what perfect cube is 130 close to? At the very end, you have 6 simplifying questions to do on your own. So give those a shot, and then we will check our answers when we come back to school. Have a good one.